Welcome back in this chapter, and this chapter is about the IIoT. So, IIoT stands for Industrial Internet of Things, which consists of the sensors, which consist of instruments, machines, and other devices that are networked together and use internet connectivity to enhance industrial and manufacturing business process and applications. So this is the standard definition of IIoT. So what I said that IIoT contains all these field instrumentations, machines, everything networked together to the industrial applications using internet, basically in other terms. So as OT and IT systems continue to converge and the systems become more interconnected, control of physical processes remains a relatively unique and critical concept of the OT. So basically, IoT Consortium is a governing body which controls and releases the guidelines for IIoT. So they have given a three-tier model. So that three-tier model is one of the cloud, or we can say enterprise model, enterprise layer. And then we have a platform where multiple networks could be there, and third one is the edge tier. So where edge devices and everything lies out. And there is a one more segregation that is similar to that, but it is a layer. So here device layer is there, and which contains CPS, machines, hardware. So all these are in the device layer. Then we have the network layer. So it could be a Bluetooth communication, LoRa communication, cellular communication, or Wi-Fi communication. So that is a network layer where we have established all the communications from these devices. Then we have service layer. So service layer will reside either on the edge or on the cloud. So it could be applications, softwares to analyze data and transform into actionable information. So this is the service layer. Then we have content layer. So user content layer will be on the top in enterprise. So user interface devices, example, computer screens, stations, tablet, smart glasses, smart surfaces. So everything will be in the content layer where user can see all those content. So here one term, if we do not explain what is edge and edge computing, then it won't be useful. So edge computing is a decentralized computing infrastructure in which computing resources and application services can be distributed along the communication path between the data source and the cloud. So if we are putting, if in IoT there is a edge computing, and edge computing is a decentralized computing infrastructure. It is not like some computing is happening at a particular location. So this computing is distributed from bottom to top at each layer. So some computing will happen at this layer, some computation will happen at this place. Only in the network, like where transmission is happening, there won't be anything, but again when it reaches to cloud there will be some computing. So this computing is distributed on a on this vertical, so that it is not concentrated at a particular segment. Like in DCS you have seen that all computations are happening at the controller level. In PLC also computation is being performed by the controllers mainly, but here what is happening, like even the devices are smart, they are doing some computation. Then edge devices which is collecting, or the hub, IoT hub, that is also doing some type of computation. Or the gateways, what is receiving data and forwarding only the metadata to the top, to the clouds, that is also doing some computation. Then internet cloud, where this IoT uh, algorithm is hosted, then that is also doing the computation. So at every layers this computation is happening here. So edge is not merely a way to collect data, like if we are putting a RTD, a thermocouple in DCS, so that cannot do any type of computation. That is just collecting the data and forwarding it to DCS. But in IoT it is not happening that. If we are putting a sensor, smart sensor, then it is collecting some data and it is doing some sort of processing, and then only it forwarded above. So edge is not merely a way to collect data for transmission to the data center or cloud. It also processes, analyzes, and acts on data collected at the edge, and therefore essential for optimizing industrial data at every aspect of the operation. So there are some benefits of IoT system architecture. One, it could be peer-to-peer networking, like security cameras communicated about identified objects. So if one camera has identified anything, it can share that information or that learning to the other camera so that they can also identify the same object. Then next is the edge device collaboration, like wind turbines in remote locations. They can also do processing and give output to the user in the field itself without going even to the cloud. So that is edge device collaboration. Then distributed queries across data stored in devices, in cloud, anywhere in between. You can access any of the data from there. Then distributed data management, defining where and what data to be stored and how long. We can set like how much data this edge gateway can contain, how much data this edge device will retain. So those can be configured. Data governance including quality, discovery, usability, privacy, security. So multiple things we can do, because even your sensors are very smart. They have all those compute power, they have communication power, they have retaining archiving powers also. So all in all, this IoT architecture is booming, and we need to focus on the cyber security requirements as well. We need to see the what is that attack surface of these environments, and we need to design technical controls as required, depending on the threat actors, threat scenarios, and risks involved in the IoT. So that's all about the IoT architecture. Let's move to the next topic.